Welcome to Chapter 3. We've just got one topic only in Chapter 3, which is this thing called the determinant. So we're only doing two sections out of Chapter 3. 3.1, we're getting the computations. 3.2, we're getting a little bit more of the theory. But first of all, if you haven't yet watched the 3 blue, 1 brown YouTube video that I recommended at the top of this page, please do. I think it's really important to have a graphical understanding of what the determinant does. Otherwise, it just feels like some random computations that you're doing for who knows what reason. But just to recap that, remember that the determinant basically finds area or volume if you're in 3 dimensions, or meta volume if you're in more than 3 dimensions. But the basic idea is if you have, in the 2 by 2 case, if you've got some 2 by 2 matrix, then the determinant actually gives the area formed by the parallelogram. So if you look at the columns of the matrix as vectors, which we always can, then if you look at the vector AB here, and you look at this vector CD as the other vector, CD, then the parallelogram that those two vectors determine, its area is AD minus BC, and in general that's the formula for the determinant of a 2 by 2 matrix. It is the main diagonal AD, that product, minus the off diagonal, minus BC. And as you saw in the previous video, this determinant can either be positive, which means you've sort of kept your original orientation, or it can be negative, which means effectively that the shape has been flipped over. And the vector that used to point to the right now points more to the left. And of course, if AD minus BC comes out to 0, that means that the two vectors point in the same direction, and the area of the parallelogram is 0. And that means other things about like linear dependence and lots of other things. It's going to tie into our invertible matrix theorem and give us even more statements there. But we're not there yet. That's foreshadowing. Okay, so that's the idea for a 2 by 2, and you can actually sit down graphically and draw some triangles and get this AD minus BC. I'm not going to do that. I am just going to remind you that when we had the little formula for the inverse of a 2 by 2, part of the formula for the inverse, I don't know if you remember, it was 1 over AD minus BC, and then you had to do some stuff with the A and the D and the B and the C, which was swapping the main diagonal and changing the signs on the off diagonal. But really, I just want to point out that we've seen this AD minus BC before. Okay, and likewise for a 3 by 3, if you are, oops, I'll get my face out of the way here. If you are doing a 3 by 3, if you've got vectors that make up the columns, I'll use the pictures notation here, and I'll call them R1, R2, and R3. But keep in mind those are columns. So the R1, if you look at that as a vector, and that becomes that one, and then you get your other two, and between the 3 of them, it traces out a parallelepiped, which is a beautiful word to say, and the determinant will give you the volume of this parallelepiped. And what we don't yet know is how to actually numerically do that. So let's get the numerical computations for finding a 3 by 3. There I am again. Okay. So there's something called cofactor expansion, and if you've done maybe Calc 3 or another class or two, you might have seen this before, primarily in Calc 3 or some other place where you did the cross product. But in general, the idea of a cofactor expansion is to pick a row or a column, and it can be any row or any column. I think for my example here, I'm just going to pick the top row. So my choice is going to be top row. And you go entry by entry through that top row. So you start with a 2, then the -1, and then the 5. So you start with a 2, and it's going to be 2 times, and when you're using 2, this is the cofactor expansion part, when you're using 2, you cross out 2's column and you cross out 2's row, and you do the determinant of what's left. And of course what's left is a 2 by 2. We already know how to find the determinant of a 2 by 2. It's AD 4 times 8 minus BC minus 3 times -5. So that would be 4 times 8 minus 3 times -5. And this is 2 times the determinant of what's left when you cross out 2's row and 2's column, which is called the cofactor. So the determinant of the cofactor. So we do the same thing for the next entry in the row. So go over to -1 and say, we'll basically do the same thing. We're going to say it's -1 times, here maybe we'll use red this time, times, and then we cross out -1's row and -1's column, and we do the determinant of the cofactor of what's left, which would be 2 times 8 minus 4 times -5. And we keep going. We'll do the same thing with 5. There's one other important bit to notice, though, or to mention, which is the cofactor expansion alternates signs. So the top left corner, that term, the 2, is always positive, and then the next term over, whichever direction you're going, is negative, and then the next term is positive, and if there were more, you'd go negative, positive, negative, positive, however big your row or your column is that you're using. So that does mean that this -1 term here that I used is actually, so it'll be +2, and then it'll be negative of this term. So this one actually ends up being plus as well, because it started off with a -1, and then the last one, the 5, is plus. And it'll be 5, and when we cross out 5's row and 5's column, we get these 4, so that'll be 6 minus 16. I'll write it out. 2 times 3 minus 4 times 4. Okay, so let's crunch all this down. I kind of wrote everything out in extensive detail. You'll probably end up doing some of this in your head when you actually do this. But anyway, this will be 2 times 32, and this is minus a negative, so plus 15. And this one was originally -1, but the alternating signs of the determinant, we make that a plus, so plus 1 times 16, and this is minus a negative, so plus 20, and the last one is plus 5 times 6 minus 16, so minus 10, and this is just arithmetic. I say just arithmetic like we haven't all screwed up the arithmetic many times in this course. This would be, what, 47, and 16 and 20 is 36, and 5 times -10 is -50, and 2 times 47 is 94, plus 36 minus 50. Let's see, this would be 130 minus 50, so that would be 80. Hopefully I did all my arithmetic right. Okay, so that was finding the determinant of this particular 3 by 3. If you took these three vectors, 2, 2, 4, negative 1, 4, 3, 5, negative 5, 8, plotted them, in three-dimensional space, over there, over there, over there. It's going to be a terrible drawing, and if you sort of imagine this parallel pipe head that was determined by them, told you it's going to be terrible. Anyway, that thing has a volume of 80. Let me just point out that I claimed that the cofactor expansion works for picking any row or any column. So I want to just see if I can quickly do it again using a different row or column. So rather than that first row, let me just maybe pick the second column. So I'm going to choose to expand along the second column this time. So right here. And I'd like to point out that the checkerboard pattern of plus minuses always starts from the top left corner, not from where you start your row or your column. So that means that the -1 is going to be a negative, the 4 will be a positive, and the 3 will be a negative. So you always have to write out your checkerboard pattern starting from the top left corner with a plus. Okay, so we're going to start with a minus, minus 1, so we're going to start with 1. And crossing out the top row and the middle column means my cofactor determinant will be 2 times 8, so 16, minus 4 times 5, so minus -20, so plus 20. Okay, and that was actually the same as one we had done before. But now we're going down, so the next one will be, this was a minus, so the next one will be a plus. It'll be plus 4 times, and when you cross out 4's row and 4's column, that crosses out the middle row and middle column, and that gives me 2 times 8, so 16, minus 4 times 5, so 16 minus 20. And now we're on to 3, so the minus, the plus, the minus. So this will be minus 3 times, and then the cofactor expansion for 3 is crossing out the bottom row, the middle column, so that'll be 2 times -5, so it'll be -10 minus 10. Okay, hopefully this still comes out to 80. Let's find out. Let's see, we've got, this is 36 right here. Plus 4 times -4. And this is minus 3 times minus 20. So we've got 36 minus 16 plus 60. 36 minus 16 is 20 plus 60. And you can do your happy dance now because 80. It's still the same determinant, and it will be. You could pick, again, any row or any column. There's sort of 6 different options here for which row or column, and no matter which one you do, you'll always get the determinant of 80, which makes sense because it's the same 3 vectors determining the same parallelepiped, so it'll have the same volume. Okay, I think just one more video, and we'll look at a couple more computational ideas, and then we'll be done for 3.1.